Hello everyone, nice to see you again. I'm Chris. In this video is a topic about FSoE in 10 minutes. Actually, this is a presentation that I used in a factory automation community in Japan, but I translated in English and hope more people to know a little bit more about FSoE. Let's start. So before I continue to my video, let me introduce myself again. I'm Chris. I come from Hong Kong and I'm working with some stuff in factory automations. In the left hand side, you can see my radio, my blog, my YouTube, and Twitter. If you're interested about me, you can click this follow to find more about me. Okay, let's continue. So before we start, I would like to share a chart that every guys will be seeing every years. That is a chart that to show you how many nodes that is go outside the factory, and you see the top three is ProfiNet, Ethernet IP, and EtherCAT. And EtherCAT has become more and more in the market. And the topic now we are talking in this presentation is FSoE, is safety, fail safety over EtherCAT. So let us know a little bit about EtherCAT. So EtherCAT is one of the industry open field network standards with Ethernet proposed by Backoff Automations of Germany. The main features are high synchronized control, and they can be redundancies. And besides, they also have EtherCAT-P and EtherCAT-G. And the topic that we are talking this time is FSoE, is a fail-safe over EtherCAT. And I think every guys that they see this Jeff before so much time is to explain what the EtherCAT functional theories. So frame sent from the master and passed through the each slave, and Ethernet frame is sent from the master, passed through all slave in sequence, and then return to the master again. So it's the basic theory. But if so many people, at least in Japan, we will say it's the train. So let me explain a bit more about this train. Then you see this line. This line is a EtherCAT. It is the row of your train. Then the orange one is the EtherCAT master. The EtherCAT master. Then this is the start point and the end point of your EtherCAT framework. Then you have a train. What's the train? Train is your data, your frame. Then you have the stations. So station is all your EtherCAT slave in your EtherCAT network. And then you have so much data. So this guy, this very cute boys are the data. Then they go through each stations, and then the boys will go out train or go inside the train. But how to make sure that all the data is go in or go out? They will have a guide in here to check. And in EtherCAT, they will call this guide to work counters. So if this boy he go from the train, then the counter +1, and if this boy go inside the train in the station, he'll +2. Then finally, when they go back to the EtherCAT master, then they'll check the counter is same as they prefer or not. If no, that means this EtherCAT frame have problem, they will not use it. If yes, that means the EtherCAT frame have no problem, they will use it. Very simple. And so, okay, let's explain functional safety. So, and when in the factory, they have so many types of risky in our safety in our factory. It may be in case you have accident or die or environment destructions or fantastic damages. So, what kind of high risk applications in our life or in your factory? For example, CNC and robot, a very prime with some chemical, that all these high risk applications. In the factory, then you have so many types of stuff to prevent if there's any dangerous case. For example, the emission stuff for shutting down the equipment, you have 2-hand switch, you have a light guard and the long let to people to go inside the robot working area. So for the classic safety system, it should be like this. And you can see here that there will be hardware riding with some safety relay, and this is very good and very cost and not spend so much cost for the classic simple safety applications. But if your safety application become big, that means that your input and output numbers will be increased and your riding will become very complex. And even if you have any trouble, it's not easy to find out what happened in your system. And also, if you want to change your system, it will spend you so many times to rewiring your system. So, and then this is called a features called safety communications. So safety communication can have safety features and directives informations and flexibility, and is extendable. Is help you to scaling up your scale up, down, or up your system. And for the safety, you have Ethernet IP. For Ethernet IP, you have chip safety. For the ProfiNet, you have ProSafe. And for the EtherCAT, we have FSoE. This is what the topic we are covering today. So, what is safety communications? First of all, it's a very important point that it's not possible to safety communication is not a thing to promise you to communicate 100% in any conditions. It's not possible. But safety communication is only the way to ability to detect the communication error with the very high efficiency. So, what is the communication error? Should be very different way. So, for example, the message you receive in a defined cycle, or not, it is message normal or not. So, how to define this message normal? So, it's damage or loss, even loss or etc. And this is also very important thing to take care that safety communication, the rule is up to detecting that errors. So it means that after the safety communication detect that error, finally the system integrator or you need to define how to switch the machine to the safety status. And then for the safety communication, the IEC 61508 requires detector of the following communication errors: resending or duplicate message, lost message, insert message, and incorrect message, order not correct, and miss derivative, and spool message. There's so many stuff they need to detect in the safety communications. Okay, so let's do a little bit explain about what is black channels. So before black channels, actually is a case called white channels. So here the white channels, then it means that from the device to the master, you have a premium channel to do this. So if you take the so many calls, it's not easy to implement. So and then this time, some smart guy they think about they have developed the other system called black channels. So what's black channel? Black channel is that if you use the communication cables or channel that you are using in your factory, and then the receiver and the sender will check the data is saved or not, is correct or not. So by using this system for safety and non-safety data, the system it only use one communication cable. You don't need to do anything, and by some case you can use Wi-Fi also. So a little bit deep in the black channel. So here in the left hand side, you have a two device. The left hand side is a sender, the right hand side is a receiver. So we have the orange part is the safety part, and the blue is the non-safety part. And they're using the black channel to send the data from the sender to receiver. So it should be, then you inside the non-safety part, you have a non-safety data, and the safety, you have the safety data. So, and then the safety part will pass the data to the non-safety part, and then to use anything, for example, Ethernet IP or ProfiNet or something, to pass the data to the receiver. And then the receiver receives the data. For the non-safe part, the non-safe part, data, they will use it. And for the safety data, they will pass it to the safety part to let them to clarify this okay or not. And if it's okay, they will use it. And if it's not, they will just don't use it. So I told you before, it can be EtherCAT, it can be ProfiNet, it can be Ethernet IP, it can be everything. And this time, for the safety part, we are talking about is FSoE. And there's a very interesting thing that I need to point out that using the black line in here. So the black channel is the line between the safety and non-safety. So let me explain a bit more about FSoE. So FSoE is safety over EtherCAT, and one of the safety communication compatible with IEC 61508, one IEC 617 843. It's the international standard. You can use a black channel, and FSoE saved data exit as a FSoE frame is exchanged within the non-safety EtherCAT network, mixed up with the non-safety data, and is suitable for the safety application up to SIL3. And for the FSoE and black channel, let's see a bit more inside. So here is some FSoE device you can see here. Then you have a FSO, and inside there is non-safety data and safety data. And in this case, non-safe is the EtherCAT and safety is the FSoE. And this is a black channel. So EtherCAT master will send the data to the FSoE frame in. So in here, the orange one is the safety data. Then passing into the FSoE device. And this what happened to this FSoE slave, FSoE frame? He will pass to the safety part to let them do that, to clarify the data, and then to use it, or they will define to use it or not. And also, they will put the safety data back, if they have, inside the EtherCAT frame. And after that, they will send the other EtherCAT, the next EtherCAT slave. So it's a very simple. Okay, so let's explain a little bit more about the FSoE frame. The first one is the command. So here the normal FSoE frame, you have a command, you have safety data, you have CRC, you have connect ID. So command is the part that to let the slave or the receiver to know that what kind of data that you are sending to them and what is the usage of that. And defining and depends on the command that you have different types of safety data. For example, process data, you have safety input output. For the connections, you have an ID and FSoE slave address. For the reset, you have error code. So it's not possible to show you all the commands, but just show you a little bit in here. And then we have CRC. So CRC is a feature to check the data, safety data is okay or not, if it's broken or not. You can imagine like this. And so it is Japanese, but by 2 bytes, you have a 1 CRC check. So as you see here, and then finally safety 0, 1, 2, 3, 4, and I and J. And here's a little bit smart remark that FSoE should be CRC to 2 bytes. And if you use chip safety before, chip safety is used to cross-reference check. And CRC, finally, so what will happen? It means the CRC will depends on how much of FSoE data that you have. And the next part is data. So finally, if the CRC, after the CRC check, if the data is okay, then you combine all the data to generate the saved data that the device to use. And then you have a connection ID. So connection ID is an ID for the each connections. Then you need to set in the FSoE engineer tubes. Don't worry, I'll show you a bit later. So here is the frame mapping in the codice. Then you can see here they have a command, safety input, safety data or safety output data, and have a CRC and connection IDs. And here this screenshot in TrinSafe. Then you can know that this connection is the connecting to the connect ID is 9. Then you can set it in the engineer tubes. In this case, TrinSafe. Okay, so let's go a little bit deep into how the connection flow. So in the left hand side is FSoE master. In the right hand side is FSoE slave. So here you need to have a little bit some step to make a connections between FSoE slave and FSoE master and slave. For the first thing, you need to have a reset. It will be happen while the machine is startup, or you have after a communication error. Then you have a session command. Session command is a command that to tell, hey, this connection is not same as before. Please take a new one. And then you have a connection command. So in the connection command, they exchange the FSoE address and the connection ID. And then you have the parameter command, then to exchange the watchdog or safety application parameters. Then finally, then you have process data command to exchange the IO data. So as I write before in here, how to get to connected, you need to have first step, you have session ID, the exchange with session command, then you have connection ID and FSoE address exchange with the connection command, then combination and application parameter exchange with this parameters command, and finally you will have the IO data exchange with the process data command. And I would like to talk a little bit about the FSoE watchdog. So just imagine you have a FSoE master, EtherCAT master in here. Then you have FSoE slave, and you have a FSoE slave that with a FSoE master. Then you also have a EtherCAT slave, have a FSoE slave. So the frame should be flowed over like this. And EtherCAT master will send the frame to each EtherCAT slave. And also FSoE master will exchange the data to other FS slave. But in this case, you can image the slave connections. So here's the time. So how the frames pass? You will pass like this. Then EtherCAT master pass the data to the EtherCAT frame, and pass the other EtherCAT slave, and then pass back. Something like this. So the EtherCAT, the FSoE watchdog will only check the what? Check when the FSoE master send the data, and check when they receive that back for the data. Then this is a watchdog time. For the FS slave, you do have the same mechanism. And depends on the watch time. If the FSoE device they get the data inside their watchdog time setting, that they'll use that data and will not define timeout. And here a little bit they mark that if you use chip safety before, that chip safety uses time step to detect the delays. With FSoE, they use a mechanism FSoE watchdog to detect the delays. It's just I'm explaining here. Okay, let me have a summary. As a summary about the FSoE, the FSoE uses EtherCAT as a back channel, and FSoE exists as an EtherCAT slave in the EtherCAT network. What does that mean? So it means FSoE master cannot if you only have FSoE master, you cannot build a EtherCAT network. So it means that you have a EtherCAT master is required to implement FSoE network also. And ESI file is also required to build EtherCAT FSoE network. And how to deceive to use which type of safety communication, and even use safety communication or not is a case by case. Okay, so here is just a comparison here. Here is FSoE master, come back off. And if you don't have TwinCAT, don't have this EtherCAT master, actually this one will not work. It means that you need to have a EtherCAT master to generate the EtherCAT frame. And finally, I have 3 demos in here to show you after these explanations. The first one is I use the EP19570022. It is a IP67 EP FSoE master, and then I will have a EPP13220001 is a EtherCAT P junction box, and then you have a FSoE and EtherCAT P communications to a Ohina door log that support EtherCAT P and FSoE. And here, second demo, I used Codis, then with a Pulitzer FSoE master, and then connect to a safety later. And this time, I will not just use FSoE slave. I just have a normal slave called Keyens in here that to show you that safety and non-safety slave can mix in one EtherCAT network. And finally, this is also a backup controller. This I'm using CX. Why? Because I install a EL6910 in the right hand side of our controller that they build a EtherCAT communications, FSoE communication to the Phoenix contact FSoE slave. But I also have a little bit interesting functions that to work the EL61910 as a progressive master to connect to in case in here is a wide mirror and tuck. Okay, in the final, don't worry, I'll show you the demo video, and I think even if I talk more than 20 minutes, I think it's better to see the demo how it works in 5 minutes. And finally, I would like to thank so many manufacturers that they borrowed the device to me for backoff, tuck, Wago, wide mirror, Ohina, Phoenix contact, Pilis, Exa, and Paxis. I really thanks for your support to let me to do this video. Okay, so this is the time to shift our video to the live demo. Let's go. Hello everyone, here is my live demo of 10 minutes with FSoE. And I prepared 3 demos as I mentioned before, so I will first of all to explain a little bit what is that. And then with the left hand side, there is a demo with EtherCAT P and FSoE. And here the master is PackOff, TwinCAT free, and we use Ohina as a FSoE slave. And this FSoE slave is support EtherCAT.P, and here is our FSoE master. It's come from backoff, and then it's connecting local I/O that with this PDIS door lock and the e-stop. And in the middle, then we use a CODIS controller, then connecting with a PDIS FSoE master, and we communicate with the Weidmuller FSoE slave. And here is the free slot, yellow slot, voice free yellow slot FSoE slave. But we also connecting to a EtherCAT normal slave, the non-safety slave is from Kians, and also a safety ladder come from PDIS, is also a FSoE slave. And I also connect some local I/O for the to test the safety, and here is the ladder guardian come from PDIS also. And finally, in the right hand side, there's a little bit special demo that we are using a backup CX controller in here, and you can see this also is the Weidmuller controller, is a point net coupler. Here is a tag block I/O. Both of these connecting with a PortSafe, then with a EL6910. And the right hand side, that we have a EtherCAT. This EL6910 will also be a FSoE master to connecting the FedEx contacts FSoE slave. And both these three PLC, the data we're collecting to a extra touch panel. An extra touch panel, in this video, I use the web server to show you the operations. So let's start. First of all, let's log in our web panel, our touch panel. Okay, log in. And then here is our my screen that I create in here. Then I have a home. Demo 1 is showing the CODIS, and demo 2 is backup with CX controller, and demo 3 is using a normal PC that install Trinket inside, and then connecting with a FSoE master and EtherCAT.P. Okay, first one, let me show you the first demo in the left hand side. In the left hand side is connecting to a Ohina FSoE slave. So I click here, and here you can see some status. So first of all, I will plus this button to show you the status. Just wait a second. Okay, but this is normal I/O, and then we also have some safety in operations here. As see here is a switch and the e-stop and a door lock in here, right? All is connecting to this local, the FSoE master with their local I/Os. So I'll show you how to unlock this door lock, that the logic inside my FSoE master. Okay, it is just a very simple logic, but you see that I can use this button to unlock my door. So let's go through to the Trinket project in here first. I will open my Trinket project. Not this one. It's this one. It's this one. Okay. And you see the C symbol. For the EtherCAT.P is just like a EtherCAT normal slave, so you no need to do any special configurations. It's very simple. And here's some safety logic that I create in here. All this save, all the configurations and program, all the program is done by this type of blocks. So you no need to have a very deep program knowledge. You can also you also create your safety program. Okay, let's go back to camera. We go to the middle demo. It is a CODIS one. So I go to my touch panel again. I go to demo 1. Here, all the data is operation status. And then in here, here you can see the CRC and the output input command. And also, for example, I will show you some special things. For example, this is a normal key and EtherCAT slave. So I'll show you that non-safety EtherCAT slave can mix inside a safety network. You see here, I'm just slide on some data, they directly feedback back to the input. So it means that the communication is okay. And I open the white mirror. So here is the light garden. I put my hand here, and then see the output will be stopped. And then I put out my hand, and you can see the output will come back. Just me a second. Okay, great. And you can see the output will be shut down and will turn on again. But you can see it will be different between here and here. The status is different because actually this status is run inside my these two status run inside my FSoE master that please in this time. So you can very flexibly to define your program and this have a safety relay and to add delete your old logic to no need to write again. So is the advantage of using safety communications. And also in here, here is the ladder. Then you can see that it's also communicating. Let me put my hand in there. Okay, because for testing, I set the detect area is very close. So, but you know that the other data can be come back, can be feedback, and you can know is an operator is putting their hand into a working area or something. Okay, so let's go to the Codis program here. Oh, here is the Codis program. So you see here is the 4 slot I setting in the FSoE master because I have 4 FSoE slave. The first one is the safety ladder, and I have 3 FSoE slave. That's why I have 4 slots in here. And then inside you don't need to program anything here. You can just get the input or output data in here because all the logic you run inside the FSoE master of the pleats. So in here you can also need to do it very simple. You just need to feedback the output to the input. The input to the output data. That's all. Okay, that's great. So finally, let's go to the last demo in here. Is a ProtoSafe and FSoE master, FSoE communication demo. Just wait a second. Let me put my screen to be good. Okay, as you see, on the right hand side is the camera, and left hand side is my TradeGAT project. And I will also open my touch panel in here and put in here some place in here. Okay, and I will go to demo 2, and now see all is okay. The first thing I will test the ProtoSafe connection first. I will press this where is stop? I think it's this e-stop. I press this e-stop, and then I will try to touch this light garden. Please see what happened. What happened? Okay, here. Okay, and you see the light garden and e-stop signal can be feedback to my backoff controller, and then you see the light garden signal is a bit low, it's a bit slow because there is also you can also program your safety logic inside the task IOs, so that's why the light garden signal feedback will be a bit low. Okay, finally I will show you the part of the operations of Phoenix contact. Here I use the door lock and the e-stop. Just a second. Here is the e-stop at the door lock, and This one here, e-stop. Just wait a second. Okay, you can also see the door lock and the e-stop signal can be put in the fence contact. Let me get in the fence contact slave, and all the signal will be come back to my backup CX controller. Okay, I think all my demo here is finished. If you have any problem, please feel free to contact me. I will try my best to answer you from Twitter or email, everything. So please have a good day, and I hope I see you next time. Bye bye.